Welcome to Study Loop.
So for this problem, we have a set of boxes of different masses that are in a friction-free level table. So to solve this, we first need to use Newton's second law that tells us that the net force in an object is equal to the sum of all the external forces acting on it, and this is equal to the mass of the object times the acceleration of the object. So with that, we can obtain the force and also the acceleration, and with that information, we can run then from um, from greatest to least value. So for the first boss, that is boss A, we have that. First, we need to set the directions of the positive and negative directions. Just we are going to set that forces that are pointing to the right are positive and forces that are um, pointing to the left are negative. In this case, we only have forces acting on the x component, as we see in the picture. So for the first one, I'm gonna draw the forces, the diagram of forces, just to get an idea of what it's going to do with the other one. So in this case, we have the one that has a mass of 5 kilograms, and the forces that are acting on it are one to the right of 10 newtons and one to the left 5 newtons. So applying Newton's second law, we know that the sum of the forces are 10 newtons, which is positive because we set it like that, and minus 5 newtons. And this must be equal to the mass times the acceleration. So the net force, and we're going to call it net force. In this case, the net force is just 10 minus 5, that is 5 newtons. And to obtain the acceleration, we need to this net force, which is 5 newtons, we need to divide it by the mass of the boss, which is 5 kilograms. So they will give us 1 meter per second square. So this is the procedure that we need to do with all of these boxes. So for box B, we have again that we only have forces acting on the x component, on the x axis. So we just simply need to know their directions to find the net force. So sum of the forces, which is equal to the net force, is equal to, and for B, we have 10 in the minus and the minus component plus 15. And this is equal to 15 minus 10, that is 5 newtons. And we know that this is also the mass and times the acceleration. So the acceleration is 5 newtons over the mass of this, which in this case is 10 kilograms. 10 kilograms. So we obtain 0.5 meters per second square. And now for bus C, we have a negative force of 10 newtons and a positive force of 15 newtons. So it's just the same as before. The net force in this case is minus 10 plus 15 newtons. This will give us again 5 newtons, and this is time and times the acceleration. So in this case, the acceleration, but the mass for these bars is 5 kilograms. So we obtain that this is equal to 1 meter per second square. And finally, D. So in D, we have that the sum of forces equal the net force, and in this case we have a negative force of 5 newtons and a positive force of 15 newtons. So minus 5 newtons plus 15 newtons. This is equal to 10 newtons, and this is equal also to mass times the acceleration. So the acceleration is equal to 10 newtons over the mass, which is 20 kilograms for this case, for the bus D. So this is 0.5 meters per second square. So in this case, we know that we need to rank the net force and the acceleration. So from greatest to least. So forces, I'm gonna put better net force, greatest to least. So the greatest force of them all is D, because it's 10 newtons. So D is the first one because it's the greatest, and the other ones are all the same. So it doesn't matter what we put, we just simply put A is equal to B, that is equal to C. And the acceleration, again, we run them, and from greatest to least. So we found that the greatest acceleration of them all is A, that is 1, and C, that is also 1. So we put in here A equals to C, and D is equal to B, but are less than the other two. So that are in second place. D is equal to B. And this is how we rank our boxes.